Hey everybody, Mr. Tro here. Today we're gonna, whoa, that is not safe. Never want that kind of flame in a lab. Sorry about that. Today we're gonna investigate 4 different types of reactions. Now in class you may have learned about 5. There is a reaction called combustion, but we're not gonna do that in the lab. But we're gonna look at the 4 other ones, which are single replacement, double replacement, synthesis, and decomposition. Okay, so I'm going to perform these different procedures for you, and while you look at those on video, you can follow along and make observations and hopefully complete your lab as we go through. Okay, so why don't you come along with me? Here we go. Okay, so for the first reaction, we're going to take a piece of magnesium. You can see right here. Magnesium is a shiny metal, and in case it isn't shiny, we can take a little steel wool to it and shine it right up. So you should be able to see on video that that is a silver metal, okay? Now, what we're gonna do now is we're gonna react this with the air. Okay, so I'm gonna take my flame here. I'm gonna make sure I've got a nice cone, a hot flame. I'm gonna turn the lights down in the room. And we are going to stick the metal into the flame. Okay, watch what happens. Okay. Okay, so if we look at what's left of the metal, it is no longer a shiny metal. In fact, some of it is broken off and fallen right down on the counter. I can take this. If I hit it, you see a white powder kind of flakes off of it. So before, it was a metal that was very flexible. If we look here at the original magnesium, okay, I can bend it. It kind of looks like a spring. It's very flexible, like a typical foil or metal. But it's actually turned into a new substance with completely different properties. It's a different color, right? And it's more of a powder or an ash than it is a metal. Now, Mama always said that if something is good, going bigger will make it a lot more funner, right? So I've wadded up a bunch of magnesium. Let's just see what happens when we put a bunch of it in there. Whoa! Woo! Okay, so this is a piece of copper foil, copper metal. You can see it's got that brownish red hue to it that you would associate with copper, like a copper penny. It's a little shiny. It's got some shiny luster to it, but it also has these streaks on it, these discolorations on it. So what I'm gonna do is I'm going to take a piece of steel wool to the copper. I'm gonna shine it up the best I can. Okay, so if I take the copper and I take the steel wool to it, and I rub the steel wool back and forth on it, kind of like sandpaper. Hopefully, you can see how wonderfully shiny that just got. If I show you the other side, there was the original copper. This is what it looks like now. Now, when we first ordered the copper, when we first got the copper sheet looked similar to this. Super shiny, what you would imagine a metal would look like. But after sitting for a few years in a drawer, it takes on this hue, okay? Okay, so the lab calls for us to place the copper metal into an open flame, a hot flame. So I'm going to open up my barrel so that I get a nice tight cone. Now you can hear that. That almost sounds like it's angry, right? That is a nice hot flame, okay? So we're gonna take our copper and we're gonna put it in the flame. Okay. Now, as you can see, hopefully, on the side facing you, how the color has already changed. It's no longer copper colored. It might be hard to see on camera, but it's more of a silvery gray color now. On both sides, you can see where the tongs are holding it. There's a little bit of discoloration, but this no longer looks like copper. Turn the flame off, bring this near the camera. Hopefully you can see that that is definitely a grayish color. It's almost like a dark gray. I would say maybe a charcoal color. So somewhere between silver and black, so like a dark gray. Okay, now this is extremely hot. So I'm gonna place it into a ceramic dish. I'm just gonna let it cool off for a few minutes and we'll come back. Okay, so as I stated a little earlier, there appears to be almost a flaky surface to this copper metal, and you can see that if I can actually scrape away, so the surface of the copper almost created, if you look, it's a dark gray, almost black, brittle, very brittle. It breaks up when I touch it, substance. Now that is not copper, because copper, first of all, is copper colored, and copper is not brittle. Copper can be bent, it's very malleable, it can be shaped, it doesn't break up. So this is definitely a new substance that's created. Not exactly sure what it is, but if we were to scrape that outer layer away, we still... Okay, we're back now for part B of the lab. In part B of the lab, we're gonna take a look at two different substances. We're gonna take a look at copper 2 carbonate, and we're also gonna take a look at ammonium carbonate. What we're going to do with each of these is we're going to introduce them to a high level of heat, and we're going to force them to decompose. And we're going to take a look at what happens when they decompose, okay? So the very first one we're going to do is copper carbonate. As you can notice, copper carbonate is a very fine green powder. Okay? I'm going to take some of this, and we're just going to put it into a test tube. You can see that it's just a very fine green powder. Okay, I'm gonna go ahead and light the Bunsen burner and then we'll stick it in the flame and see what happens. So we're back here and I'm just gonna put the copper carbonate over the flame. So you might be able to see something start to happen. You can see a little bit of a dark color there. And I don't know if you can see it inside here, but the gas, or there is a solid that's kind of jumping around inside. You can see the little particles jumping around. It actually kind of moves. The powder kind of moves as if it's a liquid. Almost like reminds me of when you have like an air hockey table and the puck floats, kind of glides almost frictionlessly on the air hockey table. This doesn't really move like a solid right now. It moves like almost like a liquid, which is letting me know that I think there's probably a maybe a gas being formed. That's what's causing the solid to dance around. And I think that gas that's being formed is almost making the solid ride on a pocket of air or of some sort of gas. Now, the color change, it's kind of hard to see on the camera right now, but the powder is turning into almost like a charcoal color, like a black. You know, it still looks a little green, but it's almost like a charcoal type black color. Looks a little green on camera. Okay, now I'm going to do the next part of the lab. The next part of the lab says we want to test to see if the gas that's produced is carbon dioxide or if it's oxygen. I'm going to stick this wood splint down into the test tube, and you can see that when I put it in there, the flame gets extinguished. Okay, so because the flame was extinguished, that actually tells us something about what kind of gas might have been produced inside this test tube during the reaction. You guys should know that oxygen is needed for something to burn. So if there was oxygen inside of this test tube, we would expect the flame to get bigger. So it tells us that we probably don't have oxygen as one of the products in this reaction. Okay? Let's move on to the other reaction, which is ammonium carbonate. So now I've got ammonium carbonate, and you can see that it's a white crystal. It's almost like a powder. It's a white crystal. If I were to breathe it, it's got a slight odor to it. It smells a little bit like ammonia, like you would clean your floors with. I'm going to go ahead and put this in the flame, and we're going to see what happens. Okay. Something that I'm noticing right now is that there is condensation. You can see that? There's condensation inside the test tube. So this reaction is producing some sort of a liquid that's condensing here. Now this is a clear colorless liquid. We could probably assume that that might be water. Okay. Just gonna keep heating this. If we get close with the camera, let's get close here. You might see individual pieces. You can look closely, you can see the individual white crystals kind of jumping around inside the test tube. You can see them jumping around kind of like little kernels of popcorn. They're jumping around because there's some sort of gas being produced that is causing them to be displaced. Okay.
Clearly see now, maybe you can see a little better top there. The liquid that's on the top of the test tube. Okay. Continue to heat. You also see there looks like the solid is floating around.
Pocket air. Now, if you look closely, you might notice there's considerably less white solid than we started with. Okay, I'm going to do the flame test again. I'm going to stick it down in, and you see again the flame gets extinguished. Let's do it again. Put it down in the test tube, flame goes out. So again, whatever gas is being produced here is not a gas that aids in burning, aids in combustion. Now if you look, there's barely anything left in that test tube. And it is all completely gone. Just disappeared, okay? Now, we know that matter doesn't disappear, but it appears like I've made this substance disappear. But that's only because the products are all gases of some form. We also saw a liquid form, but that liquid got hot enough where it eventually boiled away and became a gas. Now, one of the other things we want to do is we want to breathe, waft it in, and I'll tell you, I've been smelling it throughout. There's a very strong, like ammonia smell, a very strong smell of what you would clean your floors with, which is ammonia, which tells me that maybe ammonia is one of the products that was produced in this reaction. Okay? So that is two different examples of decomposition reactions. Hey everybody, we are moving on to part C of our types of reactions lab. Part C, we're going to discover what happens when we do a single replacement reaction. A single replacement, as you learned in class, is when a single element encounters a compound and they switch spots. So the element replaces part of the compound. In this first part of the demonstration or the lab, we're going to use hydrochloric acid, HCl, which is a type of compound. And we're going to introduce into that zinc. Now zinc is a metal. It's not quite as shiny as the metal we used earlier, which was the magnesium metal. But it's still got a little bit of a shiny luster to it, but it's more of a grayish color to start, okay? And what I'm gonna do is I'm gonna put some hydrochloric acid into a test tube, And then I'm going to drop the zinc in, and we're going to look at what happens when we do that. So I'm going to cut here, and then we're going to focus in on that reaction. So I've got the hydrochloric acid in the test tube, and what I'm going to do now is I'm going to dump in a few pieces of zinc metal, and we're going to make observations on what we see. Here we go. So at home, hopefully you can see that there's definitely a lot of bubbling going on. Now the lab calls for us to invert a larger test tube over the top. You can see that there's a vapor inside the larger test tube. So this reaction is creating a gas for sure, but it's also creating what looks like a little bit of vapor as well. Let me feel the test tube. The test tube's definitely warm. So that vapor could be maybe some water vapor that's evaporating. And we're collecting the gas. The reason we have the test tube over the top like this is obviously the gas that's being produced is lighter than air, is less dense than air. We want to test that gas. So what we're going to do is we're going to put a match or a wood splint, a lit flame, into that test tube to see if the gas inside the test tube is flammable. Okay, I got my flame. I'm going to introduce it. Ooh, fun little pop there. Okay, I've got my flame. I'm going to stick it into the... Whoa! That was cool. Okay, so this reaction is still going with the zinc and the hydrochloric acid. I'm going to go ahead and put this into our fume hood and let it go to completion. So I'll come back to that in a few minutes and we'll take a look at it. Okay, for the second reaction as a single replacement reaction, we're going to use copper sulfate as our compound, which is a pale blue color solution. And we're going to use zinc. I'm going to use two different types of zinc. I mean, they're both the same zinc, but one is going to be a sheet of zinc, which I showed you earlier, and I actually took a file to it and I scraped off the outer layer, and you can see it looks a lot like more like a metal when I scrape away the outer layer. It's very shiny, whereas the part I didn't scrape is that dull grayish color. Okay, we're also going to use granular zinc. Granular, like grains of sand, if you will. And you can see that's a much finer silver metal, okay? That one's gonna have a little more surface area, and so that reaction probably will go a little faster. We're gonna react both of those with copper sulfate, so I'm gonna get that set up and we'll take a look at what happens. Okay, I'm gonna put the zinc foil into the copper sulfate. And kind of hard to see, but the part of the zinc that was really, really shiny is actually black now. There, get the light on a little better. You can see that it turned black immediately where I scraped it. The other side, you can see is the edges are turning black. So this is a much slower reaction than we saw with the other single replacement reaction, but looks like the outer edges of the zinc are turning a dark black color. Okay, for this next reaction, I'm zoomed in on the test tube that has the copper sulfate solution, and I'm going to dump in the granular zinc. Now the granular zinc is this very pretty silver color, and see what happens right when it hits the copper sulfate. So that immediately turned black. So that's the same reaction we saw in the one to the left. However, the one to the left took a few minutes to turn black, and now you can see it clearly. The zinc is a black color. Pretty much all throughout, it's a black color. So there's a reaction that occurred, and it occurred much more slowly. It occurred much more slowly when we had the zinc foil. But when we had the zinc powder, or the grains of zinc, it happened almost immediately. So we're here for our final step in this lab, part D, which is double replacement reactions. Double replacement reactions are similar to the single replacement we just did, but instead of it being an element and a compound, what you're going to have for the double replacement reactions are two compounds. So one element and one compound will actually jump over and knock out an element in the second compound, and they will basically swap places. So you're going to start with two different compounds, and you're going to get two totally different new compounds in the products. Okay? For this, what we're going to look at is just a very simple, quick procedure. We're going to take a solution that has potassium iodide dissolved in it and mix it with a solution that has lead nitrate dissolved in it. And we're going to see what happens when these two compounds mix. Here we go. I'm putting in potassium iodide first, which is a pale yellow color. And I'm going to introduce some lead nitrate. And watch immediately where it hits. You can see, hopefully, a bright yellow solid. Now it dissipated a little bit, so I'm going to pour some more in. And you should be able to see that there is this vibrant, bright yellow solid that's created. You can see at the bottom of the test tube there's still liquid there, and there's a solid product that's floating. If I can mix it up, it appears like it might just be a yellow colored liquid, but if I roll this along the side, you should be able to see that there are little yellow specks coating the test tube. We call that a precipitate. There's a solid that was formed. Now, if we let this settle for a few minutes, we'll cut back to it a few minutes later. If we let it sit for a few minutes, we should see the yellow solid settle out.
Chemistry makes me happy. Oh, well, that was a good idea anyway. I love chemistry. Don't you?
So I've let that reaction between potassium iodide and lead nitrate sit for a few minutes, and you can clearly see now that there is a solid sitting on the bottom of that test tube.